So, in a previous video, we talked about why our Unity UI projects comprised out of those three elements: layout, styling, and functionality files, which are UXML, USS, and C# files. Now, for now and for the next couple of minutes, let's talk about the UXML files specifically and consider whether this kind of way of storing our layout in UXML files does actually make sense, or why we are using it that way actually. Because I think this helps us to get a certain mindset, which you basically need to have when you work with UXML files to get into Flexbox and the other layout tools that we have later. So the question that I would like to answer with this video is how do we actually get to those UXML files, and why are we using UXML files and not some other form of representation of our layout that we, I mean, you could think of a lot of other ways how you could represent this, and there are other technologies doing this. Now, Unity is using UXML files, and I hope to convince you that that's actually a good idea. Now, the other term that Unity uses for its layout representation is the idea of a visual tree. And basically in this video, what I'm going to try to do is to make the step from a visual tree to a UXML file, and hopefully convince you that the UXML file is kind of a logical conclusion of a visual tree, and that a visual tree itself is a good idea to use for the kind of work that we are doing. Now, for a second now, I would ask you to forget everything that we were talking about so far. Forget all those terms, UXML, Unity, how do we structure our elements, whatever you know about your web development stuff. And just let's make this a little thought experiment for a second. And let's say that we are trying to develop or create some kind of UI system or a UI software. Now, so a general problem that we have is we want to add a couple of elements on a canvas and save or represent them in some way, because we need, since we are trying to do some piece of software, we need some way to say, well, what are the elements that we are actually having on our canvas, right? So one way to do that would be to just say, okay, we have some red, some blue, some orange element, whatever color we use. Obviously, we don't have to use color names. We could also call them 1, 2, 3 or whatever, and just kind of save those as names and say, okay, I have a file where I know I have a red, a blue, and an orange element. Now, for this kind of UI that I'm just having on the screen right now, maybe that would actually be a kind of okay representation. However, when we go one step further, and once we try to play around with our elements, what we would probably find out that when we try to do some actual practical work, some actual practical UI for whatever, whether it is a web page, a app for your smartphone, or a game, whether you doing some settings, some menus, or I don't know, some header for a website, you will start to notice that you tend to put those elements into a certain structure. You don't just throw them around everywhere on your screen, but you try to do things like putting one element into another element, putting a list of elements beneath one another, putting them next to each other, like in a tab menu or stuff like that. And so you start to realize that you are doing a little bit more than just throwing elements around. You are actually structuring them in a certain way. Now, to save that kind of UI with that kind of structure, we could still just say, okay, let's save all the particular elements. Let's just kind of write them down, and that is in a way a true and correct representation because we are kind of listing every element that we have. However, we have absolutely no information about the fact that this gray element is inside this red element and that the red element is inside the blue element. So that's actually a little bit sad because it would be great if we would have some way to have that information around just by structuring our representation of it. And so when you do just what I now said, like kind of do this kind of thinking, what is inside what and stuff like that, what is kind of the bigger thing, what is the thing inside the other thing, you could start to write your elements down in this way. You would say, okay, the blue element is the element that has all the other elements, so let's just put it at the top. Then the blue element has two things that are kind of on the first level, where there is nothing else but just the two elements on the blue elements, and this is the red and the orange element, and we could denote this like that. Now, the important thing is that they are kind of on one level, right? Because they kind of are. Those are the two elements inside the blue element. And then we would say, okay, how can we do this one step further? You would say the orange element doesn't have anything, so there's nothing to represent, but the red element has two elements again inside itself, right? And just by that, what we did is we created a visual tree. Now that visual tree has information like, for example, that the gray element is inside the blue element because it is two levels down, but it is in the red element, and the red element has the gray element. So just like that, we managed to represent all of that information about what is inside what, and that's a lot more information than we had before when we just threw the elements all together and just wrote them down. However, we are still just using all the words of the elements, right? We didn't do anything fancy. We just structured those words in a particular way that is giving us a lot more information. Now, that's very good. That's a much more useful way that we can save our layout here. There's one downside, however. If you make this really, really large, let's imagine you have 50 or even 100 elements and you have to represent them in that kind of tree, this will just as in space terms, if you want to show that will be pretty large, right? You will have a pretty large tree. So you could think, is there a way how we can still have exactly the same information, but make it a little bit more concise, a little bit more compact? And there is, and we are using this actually when you're using, I don't know, Microsoft Word or Google Docs or whatever. You use that in a hierarchical list, for example, where you say I have point, I don't know, 1, then 1A, and then 1A small a, or Roman 1 again, stuff like that. You tend to do this, and the meaning of this is exactly the same that it is for our tree. It's basically saying the blue thing is the overarching thing for all the other things, because they are intended. They have this intention, indentation, like here, the red and the orange element, and then we have one more indentation for the gray elements, and that means they are kind of again one step lower. So what our levels here are, that are kind of the bottom end of the arrows. We have one level here and another level here. The same thing represent our indentations here, where we also have like 2 level of indentation. Now, those arrows just mean that we can kind of expand the blue element because it has children, and we can expand the red element because it has children. The orange element doesn't have children, so we cannot expand that. Now, just like that, we found a different way to represent our visual tree. Now, we want to use our visual tree because it has a lot of information that we actually need. It's just a little bit clumsy for putting it into an editor or into something like Unity because it might get very large. This representation, however, is kind of handy, and we can represent even very large trees in a pretty compact way. And that's what Unity does. And it uses basically those two terms for those two things. You have your visual representation in a visual tree. That's what you should actually, that's how you should think about your layout, basically. And then in the actual hierarchy, to make it a little bit more compact, you have, I'm just saying it in the actual hierarchy. In the actual editor, you have this representation as a hierarchy, where you have exactly the same information than in the visual tree. It's just a little bit more compact. Okay, so I hope that you agree with me that the visual tree representation is a good representation for that kind of layout, and that it actually makes sense to work with it, at least much more sense than to work with unstructured data. And I hope you also agree that this hierarchy representation in pure text has exactly the same meaning as the visual tree, and we can easily identify what it has, what the meaning is. That gray is the child of red because it's indented one level deeper. Okay. Thank you so far, and in the next video we will talk a little bit more about the advantages of a visual tree representation.